Okay. So logical operators. Logical operators are that can be used. These are the operators basically and or and not. And these are the operators which can be used to create complex Boolean expressions. So and or operator are binary operators which connect two Boolean expressions into a compound Boolean expression. Not operator is a unary operator which will reverse the output of that Boolean expression. So let's say you have the two conditions from the previous slides. That is, from here you are checking like if the person is qualified for the loan based upon these two conditions, right? The person must earn at least 30,000 and must be employed for at least 2 years. So here, as these two conditions are mandatory for for someone to be qualified for a loan, you can use the and operator and then can have just one if statement instead of using if else or if else. So the statements when we are using the and operator can be if this is salary is greater than or equal to 30,000 and years is greater than or equal to 2 colon next line print you are qualified for the loan. Next else colon you are not qualified for the loan. That can be a simple structure when you are using the logical expression and. Same thing for or. So if the conditions here, if the program says at least one of these conditions must be met, so even if the person has less than $30,000 per year, but has working experience of more than 2 years, then in that case, you can just use the or operand. So you can have the statement as if salary is greater than or equal to 30,000 or years is greater than or equal to 2, print you qualify for the loan. Else you do not meet the conditions, you do not qualify for the loan. So we'll see more examples as well. So for now we have and or operators. So not operator is something that will just negate whatever you have as your result. So let's say the person is meeting those two conditions, the person is having at least 30,000 and he is employed for let's say 4 years. So that makes our conditions true, right? The total Boolean expression will be true. When you are having a not operator before that expression, it will just negate the entire truth value. So after this not expression has been used, instead of getting the value true, it will be false and false will be true. So it's vice versa. So let's take this example. Is x greater than y and a less than b? So if that is the case, if this compound expression value is true, only then the statements underneath that block will be executed. Is x equal to y or is x equal to z? If x is equal to either y or z, the value or the statements underneath this block will be executed. So is x greater than y? So let's say x value is 5 and y value is 3. That makes this expression true, right? X is greater than y. So we have 5 is greater than 3. But as you are having the not or the unary operator before that, the compound expression value will be false. The inner expression value is true, but as you are having not, the compound expression value will be false. So this is sub expression 1, sub expression 2. The entire thing is the compound expression. So that's for the terminology. So if I say the compound expression in the next lab or in the slides, don't get confused. So each of the operator has its own truth table or the logic that is with respect to that operator. So such type of, let's take this. This is for the AND operator. For AND operator to have the value as true, both the conditions must be true. Even if one of the condition is true and the other is false, the outcome is still false. If both the conditions are false, then anyway, the output is false. So for example, if the user or if the person is having greater than 30,000, but is not employed for 2 years, then he is not qualified for the loan because both the conditions must be met. So for the AND operator, both the conditions must be true or must be met for the compound expression value to be true. Similarly, for the OR operator, any expression can be true. Any expression in the compound expression, if it is true, then result of the compound expression is true. So here, even if the person is having greater than 30,000 salary, but he is not employed for greater than 2 years, he is still qualified for the loan, because as per the program, at least one of the conditions must be met. So if both the conditions are true, it is true. If any of the condition is true, then the compound expression value is true. If both of the statements or the conditions are false, then the compound expression value is false. So that is the or and operators. So for or operator, if the left operand is true, compound expression is true. Otherwise, equalate right operand. So instead of having this short circuit evaluation terminology, I would just suggest you to memorize and understand this. So depending upon the conditions and the compound expression values, you can write or design your programs. So for the not operator, if the compound expression or the sub-expression value is true, then the compound expression value will be false. If the sub-expression value is false, then the compound expression value will be true, because it's just reversing whatever you have in your expression or the condition. So we can check the numerical ranges by using the logical operands as well. So is x greater than 10 and is x less than 20? If that is the case, only if both these conditions are met, then the statements underneath this condition will be executed. Same thing for or. Is x less than 10 or is x greater than 20? If any of these conditions is met, then you can execute the statements underneath this block. So we have Boolean variables as well. Boolean variables reflect one of two values, which is true or false. This is represented by bool data type. So we will be using them as flags. So basically, you can first set the flag to false and then make the condition does not exist. And you can, after once you are writing the program, you can just change that condition to true, or you can make that flag to true. So we'll not be talking much about flags in this chapter, because we'll be using flags in chapter 5 and chapter 6. So for now, just understand that you have Boolean variables, which are true and false, true or false. So whenever we are working with all the conditions, so inside the condition, that is, let's say if x is greater than or equal to 10 and x is less than or equal to 20. Here, the outcome is true or false, right? There is also a Boolean operator, which is denoted by bool data type. Okay, so with this, we are done with the second part of the chapter 3. Next will be chapter 3, third part.